Our sun, a constant source of light and life, can also unleash powerful solar flares. These flares can disrupt communication systems and power grids, causing widespread chaos. Our technology is vulnerable to these solar outbursts. Solar flares are sudden bursts of energy from the sun. The Carrington event of 1859 and the 1989 Quebec blackout show their potential impact. Understanding these flares is crucial for protecting our infrastructure. Solar activity influences Earth's climate. Solar cycle 25, peaking around 2025, may bring more intense flares. These flares could affect our climate and technology. The sun's influence on climate is complex. Increased solar activity might exacerbate global warming or cause regional cooling. Research is essential to understand and predict these effects. Solar flares are powerful explosions on the sun's surface. They can disrupt satellites and power grids. Understanding flares helps us predict and mitigate their impacts. Historical solar storms like the Carrington event highlight the sun's power. These events disrupted technology and caused auroras far from the poles. Studying them helps us prepare for future solar activity. Solar flares result from magnetic reconnection on the sun. This process releases immense energy, affecting Earth. Understanding it aids in predicting solar activity. Solar flares interact with Earth's magnetosphere, causing auroras. These interactions can disrupt satellites and pose risks to astronauts. Research helps improve forecasts and protect technology. Satellites and ground-based observatories monitor solar activity. They provide data for predicting solar storms. Investing in these technologies is crucial for protecting our infrastructure. The solar cycle influences solar activity and flares. During solar maximum, increased activity affects Earth's climate. Understanding this cycle helps predict its impacts. Solar activity affects cosmic rays reaching Earth. These rays may influence cloud formation and climate. Research continues to explore this connection. Section 3. Unraveling the solar climate puzzle. A debate heats up. The intricate relationship between solar activity and Earth's climate has sparked intense debate within the scientific community. While there's agreement that the sun plays a fundamental role in driving our planet's climate system, the specific mechanisms by which solar variations, including the ebb and flow of the solar cycle, influence our climate remain areas of active research and, in some cases, contention. Some scientists hypothesize that increased solar activity, with its associated increase in solar radiation and potential influence on cloud cover through cosmic ray modulation, could exacerbate global warming, adding fuel to the fire already ignited by human-induced greenhouse gas emissions. This camp points to historical periods of increased solar activity coinciding with warmer periods in Earth's past. However, other researchers offer a counter-argument, suggesting that the sun's influence on climate might be more nuanced, potentially leading to regional cooling effects in certain parts of the world. They argue that the magnitude of solar variations is too small to have a significant impact on global temperatures, and that other factors, such as volcanic eruptions and internal climate variability, play a more dominant role. This scientific debate highlights the complexity of the Earth's climate system and the challenges in disentangling the various factors that influence it. While the sun's role in climate change is undeniable, the extent and nature of its influence remain subjects of ongoing investigation. The scientific community, like a detective piecing together clues from a complex crime scene, continues to gather evidence, analyze data, and refine models to better understand the intricate interplay between the sun and our planet's climate. This pursuit of knowledge is crucial for developing accurate climate projections and informing policy decisions related to climate change mitigation and adaptation strategies. Section 4. A delicate balance Earth's climate system in flux. Imagine Earth's climate system as an intricate mobile, delicately balanced, with each element interconnected and influencing the others. The sun, as the primary energy source for our planet, sits at the heart of this mobile, its radiative energy setting the entire system in motion. However, the climate system is far from static. It's constantly in flux, responding to a multitude of internal and external forces. On the one hand, we have natural climate variability, driven by factors such as volcanic eruptions, which can inject massive amounts of sunlight-reflecting aerosols into the atmosphere, causing temporary cooling, ocean currents, which redistribute heat around the globe, and natural fluctuations in greenhouse gas concentrations. On the other hand, we have human activities, primarily the burning of fossil fuels, which have dramatically increased greenhouse gas concentrations in the atmosphere, trapping heat and leading to the unprecedented warming trend observed in recent centuries. This human-induced warming is superimposed upon the backdrop of natural climate variability, making it challenging to isolate the specific contributions of each factor. Now, add to this complex mix the sun's influence, with its rhythmic solar cycles, fluctuating energy output, and potential influence on cloud cover through cosmic ray modulation. The sun's role in climate change, while undeniable, becomes entangled with other natural and anthropogenic factors, making it difficult to precisely quantify its impact. Understanding the relative contributions of these various factors is crucial for developing accurate climate models and making informed decisions about climate change mitigation and adaptation strategies. It's like trying to solve a complex jigsaw puzzle where some of the pieces are still missing, and the picture keeps changing. Section 5. Future climate projections. Factoring in the sun's influence. As scientists grapple with the complexities of Earth's climate system, one pressing question looms large. What does the future hold for our planet's climate? Developing accurate climate projections is essential for informing policy decisions, guiding adaptation strategies, and mitigating the potential impacts of a changing climate. Climate models, sophisticated computer simulations that incorporate a wide range of variables, serve as our crystal balls, offering glimpses into potential future climate scenarios. These models take into account factors such as greenhouse gas emissions, land use changes, volcanic activity, and of course, solar activity. However, incorporating the sun's influence into climate models presents a unique set of challenges. While we have a good understanding of the solar cycle's rhythm, predicting the exact magnitude of future solar cycles and their potential impacts on Earth's climate remains an area of active research. Some studies suggest that even if the sun were to enter a prolonged period of reduced activity, a so-called grand solar minimum, it would not be sufficient to offset the warming effects of human-induced greenhouse gas emissions. In other words, even a dimmer sun wouldn't be enough to counteract the warming we've already set in motion. Other research suggests that the sun's influence, while not the dominant driver of long-term climate change, could still lead to regional and seasonal climate variations. For example, some studies have linked periods of low solar activity to colder winters in certain parts of the northern hemisphere. As our understanding of the sun-climate connection evolves, so too will our ability to incorporate this knowledge into climate models, leading to more accurate and robust climate projections. These projections will be essential for guiding our response to the challenges of a changing climate, ensuring a sustainable future for generations to come. Section 1. The intensifying solar activity and global warming. As solar activity continues to escalate in intensity, its potential to exacerbate global warming remains a topic of significant scientific interest. The sun, our primary source of energy, dictates much of Earth's climate and weather patterns. However, recent increases in solar flares and other solar phenomena pose new questions about how these activities may amplify the existing trends in global warming. The connection between the sun and Earth's climate is complex, involving multiple layers of atmospheric interaction and energy exchange. Recent studies highlight a possible correlation between prolonged periods of high solar activity and increased global temperatures. This relationship suggests that solar maximum phases, characterized by an increased number of sunspots and solar flares, could enhance the natural warming of the Earth. The mechanics of this process involve the intricate balance of solar radiation absorbed by the Earth and the heat that is radiated back into space, a balance that can be tipped by increased solar energy. Moreover, the impact of solar activity extends beyond direct radiation. Solar flares in particular contribute additional ultraviolet and X-ray radiation to Earth's atmosphere, potentially altering chemical reactions in the stratosphere and affecting global atmospheric circulation patterns. These changes, while subtle, could have cumulative effects on global climate systems, further complicating the dynamics of global warming. Understanding the role of the sun in climate dynamics is crucial, not only for academic purposes, but also for practical applications in predicting and mitigating the effects of climate change. As solar activity intensifies, the need to accurately model its impact on Earth's climate becomes increasingly urgent, calling for enhanced cooperation between solar physicists and climate scientists. Section 2. Expert opinions on solar dynamics and climate change. The dialogue between astrophysicists and climatologists has intensified as both communities seek to understand the potential impacts of heightened solar activity on Earth's climate. Experts in solar physics are exploring the mechanisms by which solar flares, coronal mass ejections, and other solar phenomena might influence Earth's atmospheric dynamics. Dr. Emily Roberts, a renowned astrophysicist, emphasizes that while solar activity is just one piece of the climate puzzle, its fluctuations can lead to significant atmospheric changes that must be accounted for in climate models. Climatologists, on the other hand, are examining the historical climate data to identify patterns that might correlate with solar cycles. Dr. Jonathan Lee, a climate scientist, points out that periods of high solar activity have often coincided with global temperature anomalies. However, distinguishing the solar influence from anthropogenic effects remains a significant challenge. This intersection of solar physics and climate science is pivotal in refining our understanding of how natural and human-induced factors combine to shape our climate. There is a consensus among some experts that while the sun's influence is significant, it is unlikely to outweigh the effects of human-induced greenhouse gas emissions. Dr. Susan Choi, a specialist in atmospheric sciences, argues that the primary driver of the recent global temperature rise is undoubtedly anthropogenic. However, understanding solar contributions is critical to fully grasping the complexity of climate systems. These expert insights underscore the importance of integrating solar dynamics into broader climate discussions. As research progresses, the scientific community hopes to develop more sophisticated models that accurately reflect the contribution of solar activity to global climate variability. Section 3. Bridging astrophysics and climatology. The increasing collaboration between astrophysics and climatology is leading to groundbreaking insights into how solar phenomena affect Earth's climate system. This interdisciplinary approach involves leveraging data from solar observations and simulations to predict solar cycles and their potential impacts on climate. Advanced computational models now incorporate solar data to simulate possible climate outcomes under different scenarios of solar activity. One of the key areas of focus is the study of solar irradiance and its effect on Earth's energy balance. Solar irradiance, the sun's output of radiant energy, varies with the number of sunspots and other solar activities. By understanding these variations, scientists can better predict how changes in solar irradiance might influence global temperatures and weather patterns. Furthermore, this collaboration has spurred the development of new technologies and methodologies for monitoring solar activity. Satellites equipped with sophisticated sensors now provide real-time data on solar flares and sunspots, which are crucial for updating climate models. These technological advancements not only enhance our ability to monitor solar activity, but also improve our predictive capabilities regarding its impact on Earth's climate. As this scientific partnership matures, it promises to enhance our predictive accuracy and deepen our understanding of the complex interplay between the Sun and Earth's climate system. This knowledge is essential for formulating effective strategies to mitigate and adapt to the effects of climate change, ensuring a sustainable future for the planet. Section 4. The role of solar research in climate policy. The implications of solar research extend beyond academia into the realm of climate policy. Policymakers increasingly recognize the importance of incorporating solar activity data into climate strategies. This integration is crucial for developing robust policies that are capable of addressing not only the anthropogenic causes of climate change, but also its natural influences. National and international policy frameworks are beginning to include considerations of solar activity in their climate adaptation and mitigation strategies. For instance, the United Nations Framework Convention on Climate Change, UNFCCC, now acknowledges the role of solar variations in its assessments and encourages member countries to factor solar data into their environmental planning and risk management processes. Moreover, the insights gained from solar research are influencing policies related to energy, agriculture, and disaster preparedness. For example, understanding the potential for increased solar activity to disrupt satellite communications and power grids can inform infrastructure resilience initiatives. Additionally, anticipating changes in weather patterns influenced by solar dynamics can aid in agricultural planning, helping to secure food resources in the face of climate variability. As solar research continues to evolve, its integration into climate policy will likely deepen, offering more refined tools for addressing the multifaceted challenges of climate change. This proactive approach in policymaking is essential for harnessing scientific insights to safeguard and sustainably manage our planet's future. Section 5. Public perception and scientific communication. The way in which solar activity and its impact on climate change are communicated to the public plays a pivotal role in shaping perceptions and driving collective action. Clear, accurate, and engaging communication is essential to bridge the gap between complex scientific concepts and public understanding. This task is often complicated by the inherently uncertain nature of both solar and climate sciences, which can lead to misunderstandings or skepticism among the general populace. Efforts to improve scientific communication about solar activity and climate change involve multiple strategies. Media outlets, educational institutions, and scientific organizations are increasingly using visual aids, interactive platforms, and narrative storytelling to convey the complexities of how solar activity influences climate. These tools not only help demystify the science, but also engage people in a way that prompts informed discussion and thoughtful consideration of the issues. Moreover, public outreach programs that involve community participation in climate and solar monitoring projects have proven effective in increasing scientific literacy and interest. These citizen science initiatives empower individuals by making them active participants in the scientific process, thereby fostering a deeper connection to the topic and a greater appreciation for the importance of solar research in understanding climate change. As we progress in our scientific endeavors to unravel the intricate relationship between the sun and our climate, continued emphasis on effective communication will be crucial. By enhancing public understanding and involvement, we can ensure a more informed and proactive response to the challenges posed by climate change, driven by both human activity and solar dynamics. As we peer into the future, the specter of climate change looms large, a complex tapestry woven from the threads of human activity and the sun's powerful influence. Our planet, once a haven of relative climatic stability, now faces a new reality, one where the sun's energy, the very lifeblood of our world, could amplify the warming trends we've set in motion. Imagine a future where the sun's radiance, once a source of comfort and sustenance, becomes a force to be reckoned with. Rising global temperatures fueled by a potent cocktail of greenhouse gases and heightened solar activity could reshape our world in profound ways. Coastal cities, once teeming with life, might face the encroaching sea, their bustling streets transformed into watery canals. Inland, vast stretches of fertile farmland could succumb to drought, transforming into arid wastelands, while extreme weather events, hurricanes, floods, and wildfires could become more frequent and intense, leaving a trail of destruction in their wake. The delicate balance of Earth's ecosystems, already strained by human activities, could be pushed to the brink, threatening biodiversity and the intricate web of life that sustains us all. This is not a future preordained. It's a future we have the power to shape, a future where our choices today will determine the fate of generations to come. The sun's energy, while a potential amplifier of climate change, can also be a powerful ally in our quest for a sustainable future. By embracing renewable energy sources, such as solar and wind power, we can reduce our reliance on fossil fuels, mitigating the human-induced drivers of climate change while harnessing the sun's boundless energy for good. The path forward lies in understanding, adapting to, and ultimately coexisting with the awesome power of our nearest star. As the sun's activity continues its upward climb, one of the most direct and concerning consequences is the potential for rising global temperatures. The Earth's climate system, a delicate dance between incoming solar radiation and outgoing heat, is exquisitely sensitive to even subtle changes in the sun's energy output. While the sun's overall brightness remains relatively constant, fluctuations in solar activity, particularly during periods of intense solar maximum, can nudge Earth's temperature in a warmer direction. Imagine a world where heat waves, once occasional and bearable, become more frequent, more intense, and longer lasting. Cities, once temperate and comfortable, could transform into urban heat islands, their concrete jungles trapping heat and exacerbating the sweltering conditions. The elderly, the very young, and those with underlying health conditions would face heightened risks of heat stroke, heat exhaustion, and other heat-related illnesses. Agriculture, the backbone of human civilization, would face unprecedented challenges as crops wither under the relentless sun, yields decline, and food security becomes an ever-growing concern. Water resources, already strained in many parts of the world, would dwindle further as evaporation rates increase, leading to water shortages, conflicts over dwindling supplies, and mass migrations of climate refugees. The polar regions, those icy sentinels of our planet, would bear the brunt of rising temperatures, with glaciers and ice sheets melting at an accelerated pace, contributing to rising sea levels and threatening the delicate balance of these fragile ecosystems. The consequences of unchecked warming extend far beyond mere discomfort. They threaten the very fabric of our society and the well-being of countless species, including our own. The heat is on, both literally and figuratively, demanding a global response that matches the urgency of this growing crisis. The time for action is now, to mitigate the human-induced drivers of climate change and adapt to a warmer world, ensuring a livable planet for generations to come. As the planet warms under the combined influence of human activities and heightened solar activity, the atmosphere itself becomes a crucible of change, its delicate balance disrupted, its fury unleashed in the form of extreme weather events. Hurricanes, those swirling behemoths of wind and rain, could become more frequent, more intense, and capable of reaching farther inland, leaving a trail of devastation in their wake. Coastal communities, once bustling with life, could face the full brunt of these storms, their homes and businesses battered by high winds, storm surges, and torrential rainfall. Flooding, once a localized concern, could become more widespread as rivers overflow their banks, inundating homes, businesses, and critical infrastructure, displacing communities and causing billions of dollars in damage. In other regions, prolonged droughts, fueled by hotter temperatures and shifting precipitation patterns, could parch the land, turning once fertile fields into barren wastelands. Wildfires, fueled by dry conditions and tinderbox-like vegetation, could rage across vast swaths of forest, releasing tons of carbon dioxide into the atmosphere, further exacerbating the cycle of warming. The human toll of these extreme events would be immeasurable. Lives lost, homes destroyed, livelihoods disrupted. The economic costs would be staggering as nations struggle to rebuild infrastructure, provide disaster relief, and cope with the cascading impacts of a climate in turmoil. The very fabric of our society, our sense of security, and our connection to the natural world would be tested as never before. Adapting to this new era of extreme weather will require a fundamental shift in our thinking and our actions. From building more resilient infrastructure to developing early warning systems, From managing water resources more sustainably to embracing climate-smart agricultural practices, we must prepare for a future where nature's fury is an ever-present threat. In a world increasingly influenced by the sun's capricious nature, life itself will be forced to adapt, to find new ways to thrive on a planet in flux. Species will migrate, seeking cooler climes or more favorable conditions, their movements disrupting ecosystems and altering the balance of nature. Some species, unable to adapt quickly enough, may face extinction, their genetic heritage lost forever. Human societies, too, will need to adapt, to find ways to live in harmony with a sun-kissed world. Coastal communities may retreat inland, abandoning centuries-old settlements to the rising tides. Cities may embrace green infrastructure, incorporating parks, trees, and reflective surfaces to mitigate the urban heat island effect. Agriculture will need to become more resilient, relying on drought-resistant crops and water-efficient irrigation techniques to ensure food security in a changing climate. Our energy systems, too, will need to transform. Renewable energy sources, such as solar, wind, and geothermal, will become not just environmentally friendly alternatives, but essential components of a climate-resilient future. We will need to rethink our relationship with water, treating it as the precious resource it is, conserving it, reusing it, and finding ways to adapt to a world where water scarcity becomes the norm. This adaptation will require innovation, cooperation, and a willingness to embrace new ways of living. It will demand that we break down the barriers between nations, between disciplines, and between generations, working together to create a future where humanity can thrive, even as the sun's influence on our planet grows stronger. The challenges ahead are daunting, but they are not insurmountable. We are a species defined by our resilience, our ingenuity, and our capacity for compassion. By embracing the spirit of innovation and collaboration, we can navigate the challenges of a sun-kissed world, creating a future where life, in all its diversity and wonder, can continue to flourish. As we conclude our exploration of the sun's profound influence on our planet's climate, one truth remains irrefutable. The sun's embrace, while capable of both nurturing life and unleashing its fury, is an enduring constant in our cosmic story. From the dawn of time, this celestial giant has bathed our world in light and warmth, shaping the very conditions that allowed life to emerge and flourish on Earth. Yet, as we've discovered, the sun's embrace is not always gentle. Its rhythmic cycles, its occasional outbursts of energy in the form of solar flares, and its subtle influence on cosmic ray flux all play a role in shaping Earth's ever-changing climate. While the sun's influence on climate is undeniable, its precise role in the current warming trend remains an area of active scientific inquiry, a complex puzzle with pieces still being assembled. What we do know with certainty is that the sun's energy, while essential for life, is not a static force. It ebbs and flows, waxes and wanes, in ways that can have both subtle and profound effects on our planet's delicate climate balance. Understanding these solar variations, deciphering their influence on Earth's atmosphere, oceans, and ice caps, is crucial for developing accurate climate models and predicting the future of our planet's climate. The sun's embrace, while capable of both warming and disruption, is a force we must learn to live with, to adapt to, and to harness for the betterment of humanity. By embracing renewable energy sources, by developing sustainable practices, and by continuing to explore the cosmos with curiosity and wonder, we can navigate the challenges of a changing climate and create a future where the sun's enduring embrace continues to nurture life on Earth for generations to come. The challenges posed by a changing climate, influenced by both human activities and the sun's powerful hand, are not insurmountable. We are a species defined by our ingenuity, our resilience, and our capacity for collective action. The responsibility for safeguarding our planet's climate rests squarely on our shoulders, a responsibility that transcends national borders, political ideologies, and generational divides. We must become guardians of our climate destiny, embracing a future powered by clean energy, sustainable practices, and a deep respect for the interconnectedness of all life on Earth. The transition to a low-carbon economy, while challenging, is an investment in our collective future, a beacon of hope in the face of a warming world. Investing in renewable energy sources, such as solar, wind, geothermal, and tidal power, is not merely an environmental imperative. It's an economic opportunity, a chance to create new industries, jobs, and technologies that can power a sustainable future. By harnessing the sun's boundless energy, we can reduce our reliance on fossil fuels, mitigating the human-induced drivers of climate change while creating a cleaner, healthier planet for all. But technology alone is not enough. We must also embrace changes in our lifestyles, our consumption patterns, and our relationship with the natural world. Reducing our ecological footprint, conserving water, protecting forests, and embracing sustainable agricultural practices are all essential steps in mitigating our impact on the planet. The journey ahead will be long and arduous, but it's a journey we must undertake together. By harnessing our collective wisdom, our technological prowess, and our unwavering commitment to a sustainable future, we can become the guardians of our climate destiny, ensuring a livable planet for generations to come. In the grand tapestry of the cosmos, our planet is but a tiny speck, a fragile oasis of life in the vastness of space. Yet despite our insignificance in the cosmic order, we have the power to shape our destiny, to choose a path that ensures the well-being of our planet and all its inhabitants. Embracing the cosmic perspective, recognizing our interconnectedness with the sun and the universe beyond, can be a powerful motivator for change. From our vantage point on Earth, the sun may seem like an unchanging celestial constant, but as we've learned, it's a dynamic star. Its activity ebbing and flowing in ways that can have profound effects on our planet. Understanding these solar variations, unraveling their influence on Earth's climate, is not just an academic pursuit, it's a matter of planetary survival. The cosmic perspective reminds us that we are all passengers on spaceship Earth, hurtling through the cosmos together. The challenges we face, climate change, resource depletion, environmental degradation, are not confined by national borders or political ideologies. They are global challenges that demand global solutions. By embracing the cosmic perspective, by recognizing our shared responsibility for the well-being of our planet, we can transcend our differences, find common ground, and work together to create a future where humanity and nature can thrive in harmony. The time for action is now, to become stewards of our planet, to protect this precious oasis of life in the vast cosmic desert. As we stand at this pivotal moment in human history, facing the unprecedented challenges of a changing climate, one truth remains clear. Knowledge is our most powerful ally. The more we understand about our planet, about the sun's intricate influence on our climate, and about the consequences of our actions, the better equipped we'll be to make informed decisions and chart a course toward a sustainable future. Continued investment in scientific research, in space exploration, and in climate science is not an option, it's an imperative. We need more data, more observations, and more sophisticated models to understand the complex interplay of factors driving climate change. We need to invest in Earth-observing satellites, in ground-based monitoring stations, and in research expeditions to the polar regions and other climate-sensitive areas. We need to support the next generation of scientists, engineers, and policymakers, empowering them with the knowledge and tools they need to tackle the climate crisis head-on. Education, too, plays a vital role. We need to foster a greater understanding of climate science, of the sun's influence on our planet, and of the importance of sustainable practices. By empowering individuals with knowledge, we empower them to make informed choices in their daily lives and to become advocates for change. The future may seem uncertain, but one thing is clear: a future illuminated by knowledge, by scientific understanding, and by a shared commitment to protecting our planet is a future filled with hope. By embracing the power of knowledge, we can navigate the challenges ahead, ensuring a brighter future for ourselves, for generations to come, and for all life on Earth.